Hi, folks. Happy weekend. Happy week after SC. We are continuing our Dinosaur special tutorial series this week, talking about how to deploy Flux framework on AWS. So rewind, a little bit of a reminder. Flux framework is the workload manager that is developed at Lawrence Livermore National Laboratory. It is the system level scheduler that is deployed on El Capitan, which was just announced to be #1 in the top 500 list this past week. Super cool. So the high level idea here is that you too can deploy your set of nodes on Amazon, AWS EC2, bare metal, to run Flux. And this is how you can learn about it. You can play with it. You can run experiments. You can go wild. So we are going to do 2 steps today. The first thing we're going to do is build a base image using Packer. We're going to do this because we need to deploy that base image at some scale on our cluster. And it also means that you can own the base image. You can customize it. You can add your special applications or libraries. Then we're going to use Terraform to deploy. The reason we're using Terraform is because when you use a lot of sort of the pre-built, pre-packaged tools that are already provided, they tend to use something called CloudFormation on the back end. And I don't know about you, but I am extremely impatient. CloudFormation can take upwards of 15 minutes on a good day, more reasonably 15 to 20 minutes just to get your cluster up. And it's not that you're paying for the nodes the whole time. Actually, you only pay for them at like the very end, but like I want my cluster sooner than that. So anyway, so this right now, what we're looking at is the Flux tutorial series on the Converged Computing GitHub repository. I will share these links, so don't worry about taking notes or anything like that. When you go into the AWS subdirectory here, you will be met, let's make this a little bit bigger so you can see, with a bunch of subdirectories. What a surprise. And so the first thing you want to do is you want to choose the instance type that you're interested in. So step back again. AWS has this really awesome HPC family of instances. Usually the A instance types are going to be x86, and then the 7G is an ARM. The MG8 I also believe is an ARM. And the reason these are awesome, so I'm not an AWS like person, so I will tell you why I think they're awesome. You get single threading off the bat. You get a lot of the limits for sort of like memory and number of files open set to infinity or unlimited, which you'd normally want. You also, very importantly, get the entire VM. So regardless of the size that you actually choose, you get the full machine. And so that's really good. So this family of instances, they are oriented toward HPC type workloads. That's sort of my understanding of it. And as kind of another side note, now this always changes because, you know, cloud and money and whatever, but they tend to be pretty cost effective, especially the 7G. So we are going to, well, I guess we could do the 7G. Let's actually do the HPC 6A because recently I ran a bunch of experiments on that. So the first thing you want to do is build your base image, right? Actually, let's look at it in this editor. So we actually see what that looks like. So you're going to go into the build directory. And in this build script, this is basically what is being run on the machine. And so if we kind of scroll down this, you'll see what you expect. We're apt-get installing things, so dependencies, and then here's where we install EFA, the Elastic Fabric Adapter. That's how our networking is going to work. Here is where we are starting to install dependencies for Flux. So here, let's see, Purdy. I'm not actually sure how you're supposed to pronounce that, but I pronounce it Purdy. So open PMix and Purdy. Here's Flux security, generating a munge key. Here is Flux core. So note for all of these, I explicitly am setting a version. So if you build this once, if you build this twice, you will hopefully get mostly the same thing. However, if you want to change that, you should come and you should edit this file. It also helps sometimes to debug if you run into an issue. So here's Flux PMIX, Flux SCED. We generate the curve certificate, which will be shared across the nodes. And because I kind of think it's nice to have, I also wind up installing Singularity. And do I still, yep, I install Auris here. So Auris is for pushing like artifacts. And I like to have Auris because when I have like results for something, I want to easily push it to a registry. So that's the build script. Because we're using Packer, that means that you need to have Packer installed on your machine. I'll share a link for that as well. Now, to actually run the build, it's going to look like this. So this is what a packer.hcl file looks like. we're using, you know, these Amazon recipes or plugins, I suppose they're called. This is where it's saying, okay, that the source AMI, this is not an ARM instance. We want this one. We're going to call it this, but I'm going to add a test because if I don't, it's going to say this already exists. Here's the instance type, the 48x large. The 48x large gets at that t-shirt size. Now, you want to be careful about the regions here because these HPC 6A tends to be in US East 2. I believe the 7G is in US East 1. You get it wrong, it's not going to work. This is also really important because the default disk size is tiny, and you'll notice if you don't set this, it'll be like error, error, out of disk space or whatever that special error is, and you'll just be like, oh my God. But don't worry, it caches a little bit. So here is where our shell script magically goes whoop and comes in our provisioner as a shell. So if we look at actually the make file here, I have made life very easy for you because I wrote this make file that does packer init, packer format, packer validate, packer build. This takes like 20 minutes, so we're not going to wait for it to finish, but I'm going to show you what it looks like to actually run it. I'm going to make a build and yeah, it's going to go off. By the way, for all of these things that I'm doing, I have logged in with AWS credentials on my computer. You can also export them to the environment. That is up to you, but all these tools are nicely developed so that they will discover them. And yeah, okay. So while that's going, let's pretend now that we've already built the images. Side note, because we actually have. So now we move over from Hacker land into Terraform land or Tofu land, depending on your preference, right? So the way that Terraform, well, I'm not going to tell you how Terraform works, but when you open this main.terraform file, there's this section up here where you're basically going to define variables to customize, and this is called local. So the name, you can change this. Leaving it as Flux is fine. This is fine to leave the same. The region, you can also leave the same. This in these recipes is going to match the instance. Now, after your image finishes building, it's going to give you this AMI. By the way, this is a very contentious thing, whether you say AMI or AMI. I believe it means Amazon Machine Image. I always say AMI, but I go into meetings with Amazon folks and they're like, no, it's AMI, no, it's AMI, it's AMI. I'm sure they have like fights somewhere talking about this. Now, placement isn't required, but if you want to have VMs that are physically close together, you probably want to create a cluster placement group. I will show you the command to do that in the documentation that I share. Here's the instance type. These things, the networking things, so the VPC, the Ethernet, the device, the volume, you don't have to change. This min and the max size, now all of these three sizes, this should be the size that you want your cluster. I highly recommend you start testing at a small size. Like to make sure everything's working, you do not leave like 32 nodes because you might regret that. Now the key name is important because the key is going to allow you to SSH into your instance after the fact. Okay, so I will quickly just kind of show you some of these. I will scroll down and just kind of show you. So there's a startup script that runs. This generates the main broker configuration. You can take a look at this after, but that's basically going to discover the instance names and provide them to the main broker so they can all kind of talk together. Won't go into the details of that. Here's information about the subnets. There's a lot of nuances in here, like what ESA needs. It needs ingress and egress going to itself, and lots of things to figure out. But guess what? We figured out these things for you, so you don't have to. Actually, you don't have to look at this file really at all if you really didn't want to. Security groups. Here's the ingress and the egress. Let's see, is there anything else of interest in here? Permissions, that kind of thing, launch template, storage, et cetera, that's something you can customize at the top, the selector, yada, yada, yada. Okay, Vanessa, let's deploy this. So, mind you, it takes like 15 minutes to use any of those other tools that will remain nameless to deploy other kinds of clusters. So again, I've made for you a nice little make file. This is showing you what you would run if you're using Terraform. It's what you'd expect. Terraform init, Terraform format, validate, and then apply. And then at the end, we destroy because we are violent. And that's the way. The Linux kernel is pretty violent too. So we're just going to run make. And it's going to do the validate. It's going to show us stuff. And it's going to be like, do you really want to deploy this configuration? And I will be like, yes. By the way, that ICANN has zip that we kind of scroll by quickly. The reason that's there is so that it actually takes your address of your computer and makes sure to set it as a rule for SSH, so you're not just like open SSH to everyone. That's something that's required for us at the lab and probably is good practice to do. So right now, what we're watching, we're seeing the launch template. I guess we missed a lot while I was blabbing, right? Let's see, we have subnets, we have internet gateway, we have routing tables, security groups, subnet. So the subnets are interesting because you're required to have more than two, but actually for the placement group and EFA, you only really should have one. And so you actually have to create multiple, but then at the end of the day, you only direct them to use one. That's another weird kind of trick. We also need that for user space Kubernetes. We have an auto scaling group. Okay, these things are good. So just to tell you what's going to happen is this is going to finish, and then we're going to need to SSH into our instance. And so to do that, I just am lazy, I guess, and I go into the console and I go to the instance name, and then I click connect, and then I get that little connection string that's like SSH, then my key. I'll show you what that looks like. So let's see, I will probably fast forward this. Let me look at my watch that is not there, see how long this takes to do. I'll probably fast forward this in the video. Commence the Jeopardy music. 2 minutes and 10 seconds. 2 minutes and 10 seconds. 2 minutes and 20 seconds. You see how impatient this gets you? Immensely impatient. All right, so our cluster just finished. It took 3 minutes, and what I just did when I went off of camera is I went on my other computer to copy paste the SSH command to get into the cluster. Let me show you what that looks like. Just to tell you, when you go into the console and you copy paste the command, you can actually just select that top instance because that is going to be where the lead broker for Flux is running. So here's our command. I made the screen really big, so I hope you can see it. Tacos cat is our PEM. It's not, I like tacos, but unfortunately that is just my last name backwards. This is an option that I need. Identities only equals yes. And then the rest of it, I just copy pasted Ubuntu, and there's the instance address. By the way, sometimes, not in this case, it will give you the wrong username. So it may say root and you may get it denied. So in those cases, it's good to check that it's not Ubuntu and it's also not EC2 user. So let's shell in. Let's shell in. Let's shell in, shall we? I would not be a good Ninja Turtle. I get these things confused. Okay, so the first thing that I like to do when I shell into one of these clusters with Flux is do Flux resource list. This is like saying, Flux, show me what you got. And Flux says, okay, Vanessa, I have 2 nodes, 192 cores, no GPUs. Sorry, they're really hard to get in the cloud. What would you like to do? Okay, it's Flux. So let's do Flux run 2 nodes, and we're going to do the command of all time, the host name, which will actually just show you that we're actually running on 2 nodes. There they are. And so we are going to have specific tutorials that actually get into the nitty-gritty of using Flux. We're not going to do that today because we're just showing you how to deploy it on AWS. I will say Singularity is also installed on this cluster, so you can do like Singularity pull, Docker, Ubuntu. But let's do bad practice. Let's just do Singularity run. By the way, don't do this at home, kids. If you do a Singularity run across like thousands of nodes, it's just a bad idea. You want to pull your container first, just good container practices. So Singularity is good to run experiments, but this general setup is really great, not just for learning about Flux, but doing networking experiments. We use it for a lot of our HPC application experiments. It provides a bare metal equivalent for doing this. Okay, so that's the cluster. That's Flux. We'll be going into this in more detail in other tutorials, but not today. Now, what do we want to do now? Well, we want to get violent because this is what we like to do sometimes. We have all this suppressed anger. So we are going to make destroy to destroy our cluster. And this should be pretty quick. So when you do make destroy, again, let's make this a little smaller so we can see it. It's going to double check everything that's deployed, and it's gonna be like, do you really want to destroy these resources? And in my head, I have like this diabolical monster that's like, bah, ha, 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 yes, destroy all the things, like, yes. But then really, like, this experience is going on in my head, but then in the command line, I'm just like, yes, enter. It's really actually quite a funny thinking exercise to imagine like what's going on in the person's head as opposed to like the very, subtle nuanced thing they're doing and like typing a word into the command line. So in summary, what we did today is we built a base VM with Packer that has Flux installed. It has Singularity installed. It should have Oris installed. I'll need to double check that. With that base VM, we can deploy it at scale to AWS EC2 using Terraform, which is much faster than CloudFormation. Terraform will get your cluster up in a couple of minutes as opposed to 15 to 20. Once you have the cluster up, you have a system level install of Flux, just like on El Capitan, where you can run experiments, test networking. You're going to be using the Elastic Fabric adapter, which is actually pretty great. We have some experiments coming out soon that will show you that it is pretty great. And it's really awesome because Flux is not just an HPC workload manager, it also works in the cloud. This is the bare metal deployment of Flux in the cloud. We also can run it in Kubernetes. But folks, that is a tutorial for another day. So I will be posting all of these files so that you can easily use them on our GitHub. And you can expect to look forward to more fun tutorials in the future. Thanks for watching today. Talk to you later. Dinosaur out.